Hi, Assalamualaikum. My name is Nora Anis Nabila binti Nasruddin. My matrix number is H1A2319. Today, I will present about data arrangement. For the first all, the row 1, which is the only one that has fully number in the row based on table 1. The total number of column is 42. From this table, the sample size n is 42 when must use the formula to k then n. From this report, k is 5. After that is 111 minus 18 then divided by 5 equal to 18.6 and then rounded into 90. Okay, next. For the all of number on table 2, the row 1 and 2 which has full number in the row based on table 2. The total number of column is 42. From this table, the sample size n is 42 when must use the formula to k then the n. From this report, k is 6. After that, 205 minus 21 divided by 6 equal to 30.67. Then rounded into 31.
Next, we're going to talk about graphic method. We have two types of graphic method, which is histogram and OGIF. A histogram is a bar graph that represents the frequency distribution of a data set. The scale horizontal scale is quantitative and measure the data value, either class midpoint or class boundary. The vertical scale measure the frequency of the class. Consecutive bar must touch the line. Bar must begin and end at the class boundary instead of class limit. Class boundary, the number that separate classes without forming gaps between them. Lower boundary equal to lower limit minus 0.5. Upper boundary equal to upper limit plus 0.5. Next graph is OGIF graph. A commutative frequency graph or OGIF is a line graph that displays the commutative frequency of each class at its upper class boundary. Construction and OGIF. Construct a frequency distribution that includes commutative frequency as one of the column. Second, specify the horizontal and vertical scale. Horizontal, upper class boundary and vertical commutative frequency. Next, plot point that represent the upper class boundary and their corresponding commutative frequency. After that, connect the point in order from left to right. Next, the graph should start at the lower boundary of the first class commutative frequency is 0 and should end at the upper class boundary at the last class commutative frequency is equal to sample size.
Assalamualaikum. We go through the next slide measure of central tendency. First of all, my name is Muhammad Akmal Afiq bin Muhammad Jazlan. My matric number H21A2189. Mean. The mean of average is the most popular and well-known measure of central tendency. It can be used with both discrete and continuous data. The mean average of the data is found by adding all numbers in the data set and dividing by the number of values in the set. Median. The median is the middle score for a set of data that has been arranged in order of magnitude, the values separating the high half from the lower half of data sample or population or probability distribution. Mode. The value that appear most frequently in a set known as a mode, aside from the mean and median, is one of the three measures of central tendency. Mode or model value is a number that appear often in data collection. We use the formula mean. The answer for the mean of label about 5 age group in Perak, a 58.49 years old. We using the formula median is the answer about 50 of the labor force by age group in Perak, a 58.73 years old. We also use the formula mode. The answer for mode is the higher of the labor force by age group in Perak, a 76.88 years old. We use the formula mean. The answer of the mean of labor by age group.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman Adli bin Ayub. My matric number H2182173 will present measure of variation and measure of position. Next is measure of variation for each table. For the table 1, we use this formula to calculate the sample variable, which is 579.31, and then square root the value of sample variable to get standard variation, which is 24.07. For the table 2, we'll also ask the sum formula to calculate the sample variable and standard variation. The value that we get is 2325.98 for the sample variable and 48.23 for the standard variation. Next is measure of position involving interquartile range. We ask the formula to calculate upper and lower quartile using the data from the table. From the table 1, the value of quartile 3 is 79.82 and the value of quartile 1 is 27.07, and then we get the value of using interquartile range equal Q3 minus Q1 equal to 42.75. From the table 2, the value of quartile 3 is 156.5 and the value of quartile 1 is 89.94, and then we get the value of using interquartile range equal Q3 minus Q1 equal to 66.56.
Shape of the data distribution. In table 1, the total mean is 58.49, median 58.79, and mode 76.88. So the shape of the data distribution shown is skewed to the left, while in the table 2, the mean is 112.70, median 109.78, and mode is 372.5. So the shape of data distribution shown is skewed to the left.
Assalamualaikum. My name is Muhammad Ali Hamzah bin Izani. My numbermetry is H21A2199. I want to present about introduction to the data and variables involved. A. Find one set of data that have one dependent variable and one dependent variable. And this our data for our group. One independent variable is index pollution mass, and dependent variable is index pollution mean. Second, B. If the data set consists of n more than 100, then you may select at random n not greater than 100 but n must be at least 30. For example, our group chose n 85.
The next is I will discuss about compute the person product movement correlation coefficient, then interpret the regression equation. So we use the following the formula to find the person correlation coefficient. After you calculate the data, so we enter the data into the formula. R is correlation coefficient. N is the number of observations, sum of product X and Y, sum of square of value of available X and square of the sum of all value available, and so the answer get the R is 0.4. About 0.4% of the total variation in index air pollution maximum can be explained by index air pollution minimum using the regression line.
Simple linear regression. Simple linear regression formula which is equal b0 plus b1x. Estimate regression line interpretation. We use the formula to find b1 we got 5.85, and also we estimate regression line interpolation. We use the formula to find b0. We get 0.0015. Interpret the regression equation. For b0, we get the index air pollution is 0. The air pollution are 5.67 for b1 index pollution. For every index pollution, the index increase are 0.0015. That's all from my group. Thank you.